All right, for the last recording here, it's almost 10 o'clock my time, so it's a good time to start wrapping things up. We're going to talk about sleep and arousal, mention some of the products you have there as well, and kind of go over some basics here. And the first thing I want to cover is the idea that we actually all go on kind of what's called the circadian rhythm we have for sleep behavior, waking up and going to sleep. And the key structure, and I put the joy of the night shift because when you're doing the night shift, it's very difficult to keep your circadian rhythm. There's a structure that is very charismatic. It's called the suprachiasmatic nucleus. It's right above the optic chiasm, and this seems to be the key structure that kind of helps us keep our light-dark cycle going. The pineal gland has serotonin in it, and actually melatonin is a precursor to that, so that's another important structure. And when you do light therapy, if you have seasonal affective disorder, that can actually change what's going on in these areas up in the brain and can help you not be depressed and help keep you awake. So when we go to sleep, we actually have some stages of sleep that we go through. There's an appendix that kind of shows how you get hooked up to this. I know this very well because my daughter unfortunately has epilepsy, so she has to hook up to an EEG. When you're awake, like right now, you go through first beta waves. Beta waves are very high frequency, low amplitude waves. And then as you start getting more tired, you start showing alpha waves. In stage one of sleep, you have theta waves. These are higher amplitude, lower frequency. And then as you get more into your deep, slow wave sleep, you show very high amplitude, low frequency waves. And then it's very interesting. You go into kind of back up the scale and you go into REM sleep, which is sometimes called paradoxical sleep because REM is your deepest stage of sleep, but yet it looks like beta waves up there. And so you're in your deepest stage of sleep. During the night, you get more and more REM. As we get older, of course, we don't sleep nearly as well, so we wake up more at night. What we often find is if we're deprived, and they've done these studies at Stanford, if we're deprived of REM sleep for a week or a month, as they've done these studies out there, that when you actually are finally allowed to go back into sleep, you go back basically right into REM cycle, so you can kind of catch up on things. The function of sleep, the best model out there is kind of the activation synthesis that allows your mind to rest, and that the dreaming that goes on, especially during REM sleep, which does happen, you basically take what's going on in the real world and you get activated and you synthesize the information going on. So key areas of the brain, some of the neuroanatomy. We have the pineal gland, which contains melatonin, which is known to help with sleep, as some of you noted. The Raphe nucleus is another structure that contains a lot of serotonin, which also seems to be related to sleep, but not in any direct way. Many times people used to think a glass of warm milk at bedtime that contains tryptophan, which is converted into serotonin. That could really help you out, but serotonin is only not exactly related to sleep behavior. And then you have a structure called the pons, and in the pons there's a lot of acetylcholine, and right before you go into dream state, you start showing these waves starting in your pons, your lateral geniculate nucleus, which is part of your thalamus, and your occipital lobe. And this seems to be part of the idea that you're going into a dream-like state. So your pons is very active. To wake up, norepinephrine in the locus coeruleus seems to be very active, and the appendix has some information that you can add on that. Sleep disorders, the most common type that we all know about is insomnia. Now there are three different types. There's onset insomnia, where you can't fall asleep. There's maintenance insomnia, where you start waking up a lot during the night. And then termination insomnia, where you wake up too early in the morning. As far as treating these disorders, which a lot of you had thoughts on treating sleeping disorders, things like alcohol and Benadryl can be used, but the problem is you develop a dependence on them. There's insomnia rebound tolerance, and they actually decrease REM sleep. The older drugs out there used to be barbiturates, things like phenobarbital, but they became very addictive. Now they tend to use benzodiazepines, which basically there's a picture of a benzodiazepine receptor. Valium and Xanax are examples of benzodiazepines used more for anxiety. They help cause a release of GABA into the brain, and that helps you sleep a bit more, and it also helps with anxiety. And then the other drugs, Lunesta, Ambien, and Sonata, basically also help with GABA binding in sleep. Melatonin is sometimes used, and trazodone is very popular as well as a sleep and sometimes an antidepressant. Sleep hygiene is very, very important. That's where you do the right things before bedtime to make sure you sleep all right, which includes stopping your recordings at no later than 10:15, which is what I'll do tonight. Another disorder that is common is called sleep apnea, where you wake up if you are not breathing correctly, you start snoring, gasping for air. One of the most useful things to treat that are CPAPs, where you put this tube on your mouth basically in order to get the air pumping in there. Narcolepsy is another disorder where you have sleep attacks. They treat them with amphetamines. And of course, epilepsy, where your brain has so much electrical activity, they tend to give people drugs that help bind with GABA so that it slows it down, and sometimes you go unconscious into a sleep stage. So for your homework, I'd like you to go to the two professional groups I've mentioned here and kind of summarize them. And just going through the pictures, you can see the EEG monitoring the brain waves, the melatonin abstract in there, that melatonin seems to improve sleep. We've got some data on that. If you block the PGO waves, you'll see that you won't go into REM sleep, and you see the picture of that there. And then norepinephrine seems to be the thing that signals wake up. And if that's not going on, then you'll have a lot of trouble waking up as well. And then the picture of the GABA receptor. So when you take barbiturates or benzodiazepines, they basically bind and they'll cause a chloride influx, which will basically get you kind of sedated in a way and reduce anxiety as well. So hopefully this has been useful. See if you can summarize this and write it up in an outline. And that'll do it for tonight. Thank you. Bye-bye.